Think of Soviet air power, and the first thing that comes to mind is probably the mighty MiG fighter jet family. But the Soviet aviation industry began a legacy of strength and ingenuity in rotor-powered flight that rivals the best the West has to offer. Perhaps because of their country's vast and varied landscape, Soviet companies like the Kamov and Mil design bureaus have found themselves a niche with the helicopter, designing vastly different but extremely capable aircraft that serve military and civil operators throughout the world. Although fixed-wing aircraft usually get most of the attention, the idea of rotor-powered flight has been around far longer. The Italian inventor, Leonardo da Vinci, drew pictures of the flying machine that we call the helicopter more than 300 years ago. In Russia, helicopter development began before World War I, when Igor Sikorsky and B.N. Yuryev began working on helicopter designs. In 1919, during the Revolution, Sikorsky fled Russia for America, while Yuryev remained in Russia and joined SAGI. SAGI is Russia's Central Bureau of Aero and Hydrodynamics, and it was here in the late 1920s that Yuryev made the first leap in Russian helicopter development. The SAGI 1EA marked Russia's first successful experimentation with rotor-powered flight. It was one of the world's first flyable and controllable helicopters, and the first Russian helicopter to achieve real flight. The 1EA's main center rotor and small torque control rotors were powered by two 120 horsepower engines. Although the test pilot was an experienced engineer, his only flight experience was on SAGI's rotor testing rig. On early test flights, the 1EA proved difficult to control and vibrated badly on takeoff. In later tests, the front rotor was removed, and the helicopter was flown for 12 minutes at an altitude of 328 feet. After a crash in 1932, the 1EA was repaired, and that August flew to an altitude of almost 2,000 feet before the pilot lost control. But in 1935, Stalin would strike a devastating blow to Russian helicopter development. In what has become known as his Campaign of Terror, Stalin arrested dozens of leading aeronautical and aerospace engineers, including a group of Russia's best and brightest helicopter designers. Their arrests would do more damage to the development of the Russian helicopter industry than the worst crash could have done. It was not until the later years of World War II that Russia began to show its mettle as a helicopter producer. In 1951, Stalin ordered the development of a helicopter capable of lifting 5,200 pounds of military load. Work on the Yak-24 began immediately. They had 1 year to deliver the prototype. Like the Yak-100, the Yak-24 was uncannily similar in design to an American helicopter. In this case, the twin rotor machines of Frank Piasecki. In 1955, the Yak-24 made its first public appearance. In Russia, it became known as the Lataishchaya Wagon, the flying wagon, but NATO would christen it the Horse. It was the largest helicopter of its type in the world. The Yak-24 was powered by two Shvetsov radial engines, one in the front and one in the rear, that the flight engineer could access from inside during flight. During the 50s, the Yak-24 became one of Russia's primary military transports, capable of carrying up to 40 fully armed troops or 3.5 tons of cargo. Russian engineers soon mastered the design of the large single-rotor helicopter, an area in which they still had the field. Leading the Russian charge was Mikhail Leontovich Mil. He founded the Mil Design Bureau. The Bureau's first project was a 3-seat general-purpose helicopter, the Mi-1. Design work began in 1947, with test flights following a year later. In 1948, the Mi-1 was pitted against a twin-rotor Protukhin helicopter and Yakovlev's Yak-100. The Mi-1 was the victor. That August, it became the first Russian helicopter to enter series production. It is here that Mikhail Mil's legacy of great Soviet helicopters was born. In 1951, Mil expanded upon the design of the Mi-1 with a slightly larger helicopter, the Mi-2. The Mi-2 was Russia's first turbine-powered chopper and was produced in transport, rescue, cargo, and agricultural configurations. In response to an edict from Stalin for a rapid advance in Soviet helicopter technology, Mil embarked on its second challenge, the Mi-4 Hound. The first prototype was ready for test flights in only 7 months. The Mi-4 had 4 times the load-carrying capacity of the Mi-1, ranging from light army vehicles to 14 fully equipped troops. It would later become Russia's first armed helicopter. Initially, the Mi-4 was seen as a copy of Sikorsky's S-55, but with closer examination it was found to be much larger. In fact, its rotor blades were 15 feet greater in diameter, and its maximum takeoff weight was double that of the Sikorsky S-55. Early Mi-4s were fitted with wooden rotor blades that had a very limited service life. Later models received longer-lasting all-metal blades. The Mi-4's weight-to-altitude performance was tremendous. In 1956, it established 3 international records, including a flight that lifted 2,225 pounds of cargo to an altitude of 25,000 feet. But the Mi-4 functioned as more than just a military vehicle. Some were fitted with search radar for use in anti-submarine warfare. Others performed search and rescue operations and could carry up to 8 stretchers and an attendant. A civil version of the Mi-4 was developed with soundproofing, large rectangular windows, and seating for up to 10 passengers. This configuration was used by Aeroflot as feeder aircraft. All configurations of the Mi-4 could be outfitted with floats or with a crane that was capable of lifting weights up to 450 pounds. With the success of the Mi-4, Russian leaders soon recognized the helicopter's potential. An aircraft that did not require vast lengths of runways was of particular use in Russia, where the weather and terrain left some areas completely inaccessible. A helicopter could operate from the deck of an icebreaker and reach places that even the huge ships themselves couldn't get to. In 1957, the first of 5 Mi-6 prototypes took to the air. At the time, it was well and truly the largest helicopter in the world. Not only was it the largest helicopter in the world, it was also the fastest and the strongest. In 1957, the Mi-6 established a weight-to-height record of just over 10 tons, a record that it would eventually break itself by lifting double that weight to a height of 9,000 feet. Its great lifting ability was due to 2 factors. Firstly, the Mi-6 was fitted with detachable variable incidence shoulder wings. During straight and level flight, the wings carried 20% of the aircraft's weight, therefore reducing the stress on the rotors. Secondly, the Mi-6 was one of the first Russian helicopters to use turbine power. The Mi-6 was the result of a need by both military and civil factions for a heavy transport helicopter. It was capable of carrying loads both externally and internally. NATO gave the Mi-6 the title Hook. Used by the military to transport armored vehicles and large numbers of troops, the Hook broadened the margins of mobile warfare. The Mi-6 also serves as the flying laboratory Aquarius. Fitted with de-icing system components for various MIL helicopters, the Aquarius reduces the time and expense involved in testing the equipment in flight. In the midst of a team of giants, the tiny Mi-7 seemed overshadowed, but its claim to fame stood in its power source. The little helicopter looked unlike any other MIL design and was powered by subsonic ramjets attached to the tips of its rotors. MIL's legacy of great helicopters continued with the Mi-8. Although it was not a giant like the Mi-6, the Mi-8's versatility made it the most highly produced helicopter in the world. Built as a turbine-powered derivative of the Mi-4 Hound, the advancement of the new design moved so rapidly that few of the Mi-4's features remained. The Mi-8 kept the rotors, transmission, and tail boom from the Mi-4, but the rest is all its own. The engine was set higher in the extended fuselage, leaving all of the interior available for use. Originally, the Mi-8 prototype was fitted with a single engine and a 4-bladed rotor. In 1962, a second prototype was unveiled, featuring twin engines. And in 1964, a further variation with a 5-bladed rotor was introduced. This was the version that was adopted as the standard Warsaw Pact medium transport helicopter. The Mi-8 was employed in a variety of both military and civilian roles. Its primary military role was that of an assault troop carrier, but its basic purpose was expanded on with the addition of equipment for electronic warfare, communications jamming, and airborne command. Its rear-loading shell doors allow use of the full width of the fuselage for larger loads, such as military vehicles and infantry weapons. Most Mi-8s are armed, usually with rockets, and fitted with pivoting small arms mounts in the windows. As a civil aircraft, the Mi-8 was especially useful to construction and industry because it could carry cargo of nearly 7,000 pounds in an external sling. The Mi-8 was also ideal for the role of a firefighter. Its external sling could lower firefighters into areas that could never be reached by land. An asset to both military and civil operators was the Mi-8's state-of-the-art autopilot. The 4-axis system provides excellent roll, pitch, yaw, and attitude control, even in the most unfriendly of flight conditions. In 1969, an amphibian version of the Mi-8 was developed. The Mi-14 was a true amphibian, in that its hull was its source of flotation, and it did not need to be fitted with floats. In addition, the Mi-14 was fitted with retractable landing gear, allowing it to operate as easily out of the water as it did in the water. The Mi-14 began its service life in 1979. Its primary role was anti-submarine activity and search and rescue. The Mi-8 was the epitome of everything the Mill Design Bureau had set out to achieve. It was tough, strong, fast, and versatile. A classic example of a Russian helicopter. Mill continued its tradition of giant helicopters with the development of the Mi-10 that flew for the first time in 1960. This mammoth helicopter was a derivative of Mill's first giant, the Mi-6. But its slender fuselage optimized its role as a flying crane. The narrow fuselage gives the illusion of a longer frame, but the Mi-6 and the Mi-10 are actually the same length. The Mi-10 followed the Mi-6 in that it retained the original rotor, power plant, and transmission. It is here that the similarities end. Its long, spindly legs lift the flying crane 25.5 feet from the ground, enhancing its ability to lift heavy loads by taxiing over its cargo for pickup. It's also fitted with an interchangeable system of wheeled cargo platforms that can be loaded with payload and suspended below the fuselage for carriage. Unloading the platform is remarkably simple. A ramp fastened to the front of the platform can be extended to the ground, and vehicles can be driven straight off without any need for the platform to be detached from the chopper. The platform system was capable of carrying about 12 tons, while internally the Mi-10 could carry additional cargo, or up to 28 passengers. In 1964, the Mi-10 was superseded by the updated Mi-10K, designed specifically to carry slung cargo. This version of the flying crane was fitted with more powerful engines and had its landing gear shortened by 2 meters. It was fitted with a rear-facing gondola seat below the nose that housed the second pilot. From here, the pilot had complete control of both the chopper and the cargo. While both the Mi-6 and Mi-10 models were giants by any standard, the single most impressive factor is that both choppers carried their heavy loads using only a single rotor. Mill's next challenge was the Mi-12, a massive twin-rotor helicopter. The Mi-12 remains the largest helicopter in the world. The Mi-12 is essentially a combination of 2 Mi-6s. Mill took the rotor, transmission, and power plant of the Mi-6 and placed one on each of the Mi-12's wings. The counter-rotating rotors did away with the need for a tail rotor. It was replaced with a tail fin with both rudders and elevators. The huge fuselage had 2 flight decks. The lower one housed the pilot, engineer, and electrician, and the upper deck the navigator and radio operator. The cargo area had large rear-opening clamshell doors, as well as 3 sliding side doors. The internal walls were fitted with 50 fold-down seats for crew, while the center of the aircraft was left free for cargo. The Mi-12 had a built-in portable crane that could lift up to 10 tons. In 1968, the prototype flew for the first time, and while these early test flights may have cost the designers a few nights' sleep, their fears would soon be put to rest. On the 6th of August, 1969, the Mi-12 lifted a load of just over 40 tons to a height of nearly 7,500 feet, establishing a record that remains unbroken today. It was not until these records were submitted for accreditation that the Western world became aware of the existence of Mill's giant chopper. The Mi-12's safety features were also impressive. It was fitted with a system of cross shafts that connected the 4 engines, enabling both rotors to continue operating in the event that an engine failed. The Mi-12 was designed to operate even if both engines on one side failed. In 1971, the Mi-12 attended the Paris Air Show, giving Western helicopter manufacturers an opportunity to gaze in awe at the massive twin-rotor aircraft. On its return to Russia, the Mi-12 all but disappeared. Rumors circulated that it had begun service, but in fact, the project had been canceled, and the Mill Bureau began work on another heavy-lift helicopter. After the cancellation of the Mi-12 project, the Mill Bureau returned to work on its standard single-rotor helicopters. In 1975, the Mi-26 made its first flight. Although the Mi-26 looks similar to the Mi-6, it is here that the similarity ends. The rotor diameter of the Mi-26 is 9 feet smaller than the Mi-6, and designers were relying on rotor efficiency to provide the extra lift. In the early stages of design, the rotors were not available for testing, so the blades of an Mi-6 were shortened and added to a test rig. Eventually, the Mi-26 rotor became available, and it was here that Mill designers knew they would face their problems. In the West, it was generally considered that a rotor with more than 7 blades would drop in efficiency. The Mi-26 designer, Marat Teschenko, knew better and installed the chopper's 8-bladed rotor on an Mi-6 test bed. The Mi-6 fitted with the new rotor was put through a series of tests, ironing out kinks in the rotor well before the Mi-26 fuselage was available. The overall design of the Mi-26 is 4% more efficient than the Mi-6. The giant helicopter boasts a power plant with nearly double the output of that of the Mi-6. This gives it the power to lift up to 20 tons, 66% more than its predecessor. The primary role of the new chopper is as a heavy-lift helicopter intended for use in Russia's underdeveloped regions, where climate and terrain are at their most extreme. The Mi-26 is used by the military in a multitude of roles, including troop and equipment transport and casualty evacuation. Its heavy lift capabilities make the Mi-26 ideal for work in civil construction. Here, an Mi-26 is mounting a 10-ton air conditioning unit on the roof of a Moscow hotel. Mill is famous for more than just its giant helicopters. The best-known Mill chopper in the West is the legendary gunship, the Mi-24 Hind. The Mi-24 was originally designed to deliver 8 fully armed troops to the battlefield. Its weapons were purely defensive, designed for use in support of this function. Because Russian military doctrine didn't allow for a dedicated attack helicopter, designers had to combine the weapons and armament of an attack helicopter with the size and strength of a troop carrier. The result was a gunship, much larger than any of those operated by the West. Although it is a smaller machine than the Mi-8, the Mi-24 can carry a cargo of 12 fully outfitted soldiers who can unload quickly through the large sliding side door. Early models placed the 3-man crew in a level cockpit-type flight deck with sliding windows that could be opened during flight or used for defensive machine guns. Later models, starting with the Hind D, introduced a forward fuselage that featured tandem canopies and 2 separate cockpits. This layout reduced the risk of one hit disabling both crew members. The Heinz weapon system is both extensive and complex. The nose turret carries a 12.7mm cannon, while rockets and anti-tank missiles are mounted on its broad stub wings. With such a comprehensive weapon system, the Hind is able to function in a number of different roles. As a troop carrier, the Mi-24 can act as its own escort by using its nose gun as a defensive weapon. Anti-tank missiles make the Hind a tank killer, or it can operate simply as a troop carrier. Unlike many Russian helicopters, the Mi-24 requires little physical effort to fly. Its fighter-like handling, diversity, and light controls make it a favorite with flight crews. It was not until the war between Russia and Afghanistan that the Hind was able to prove its worth. The main threat to the Mi-24 in Afghanistan was the Stinger missile. Small and portable, the Stinger was an ideal weapon for the Mujahideen, allowing them to appear from nowhere to fire at the mighty helicopters. The Mi-24's defense was to release bright flares, a standard infrared countermeasure. Although the Stinger developed a reputation for unreliability and poor accuracy, many Russian aircraft fell victim to the Mujahideen's missiles. Despite fierce and elusive opposition, the Mi-24 performed gallantly, confirming its reputation as a superb combat helicopter. Mill's first true helicopter gunship made its maiden flight in November of 1982. The Mi-28 Havoc is the successor of the Mi-24 and shares the same engines and rotor size. Although it is not blessed with the Mi-24's troop-carrying capability, it is smaller and far less vulnerable. Unlike its Western counterparts that were designed to attack from concealed positions, the Mi-28 operates more like a dive bomber. The Havoc is so maneuverable that it's capable of performing a complete 360-degree loop. The Havoc is impressively armed with a 30mm nose cannon capable of firing up to 900 rounds per minute. Its stub wings are capable of carrying 16 anti-tank missiles, 40 rockets, or 2 air-to-air missiles. While the Mi-28 is more than capable of wreaking havoc on its adversaries, it is also fully prepared to protect its crews in the event of a disabling hit. Its landing gear and cockpit seats are designed to protect the crew during a crash, at fall rates of up to 50 feet per second. Should the fuel tanks take a direct hit, they will neither leak, catch fire, or explode. Both its doors and wings blast away from the aircraft in the event that the crew needs to parachute, and if the crew is unable to jump, an inflatable chute deploys beneath the doors. On the battlefield, the Havoc operates in air-to-air, search and rescue, anti-tank, and attack roles. In 1982, the Mi-28 was ready to begin full service with the Russian independent forces. But Kamov's Ka-50 beat it to the punch. After the 1986 Chernobyl nuclear reactor explosion, a team that included Mi-26, Mi-8, Mi-17, and Mi-24 radiation scout helicopters took part in a massive rescue and containment operation over the reactor site. Dozens of helicopters flew above the reactor, accurately dropping lead and silicon oxide into the crater in an effort to stop the spread of nuclear radiation. Thousands of tons of equipment were delivered to rescue workers at the site. No less than 30 helicopters were in the air above the reactor at any one time. While the operation succeeded in confining the radiation to as small an area as possible, it did so at the cost of the lives of many of the helicopter crews involved. Started in 1929 by Nikolai Kamov, the Kamov Design Bureau focuses primarily on helicopters with twin, coaxial rotors that share the same shaft. The one exception to the rule was the Ka-22 Ventokryl. The Ka-22 was an early effort in combining the advantages of a fixed-wing aircraft with those of a helicopter. It combined the body of a conventional fixed-wing transport with twin turboprop-driven rotors mounted on either wing. Mounted on the lower front tip of each wing was a four-bladed propeller. The engines were shared by both the rotors and propellers, with the former being used for vertical flight and the latter for cruise. The Ka-22 set a number of records in its time, including a lifting weight record of nearly 16.5 tons to a height of around 650 feet. Only one Ka-22 was ever produced, perhaps because in the end the design proved unrealistic for both military and civil service. Kamov's use of coaxial rotors created a helicopter that, because of its compact fuselage and lack of a long tail boom, was perfect for shipboard use. Placed one above the other, Kamov's rotors each turn in the opposite direction, eliminating the need for a tail rotor. Powered by twin turboshaft engines, the Ka-25 is fully outfitted with powered controls, all-weather communication and navigation equipment, and auto-stabilization features. It also features independent fuel supplies for each engine, a characteristic rarely found in Russian helicopters. Ka-25s are commonly used on aircraft carriers and cruisers, but are also stationed at land bases. The Hormone B functions primarily as a targeting system, or flying crow's nest, by using its radar to provide guidance data for long-range missiles launched from either ships or submarines. The Hormone A is outfitted with electronic surveillance equipment, radar and sonar equipment, and a magnetic anomaly detector. The Hormone C was developed as a search and rescue vehicle. It can accommodate up to 12 passengers with provisions for stretchers. It is also equipped with a searchlight and loudspeaker, homing receiver, winch, and auxiliary fuel tanks. A vast majority of Ka-25s are fitted with emergency flotation boots that are located on each of the 4 landing gear legs. In the event that the pilot has to ditch into the water, these boots inflate automatically. The Ka-29 Helix is an assault transport designed to ferry troops ashore during amphibious landings. Its armaments include wing-mounted rocket launchers and a retractable nose gun. Unlike many choppers, its side door does not slide open, but swings on hinges for its cargo of 16 fully armed troops to disembark as quickly as possible. This is the Ka-32. It is a simplified utility helicopter designed with both civil and military operators in mind. The Ka-32 is a genuine all-weather aircraft. The engine intakes have a dedicated heating system. The rotor blades are corrosion-proof and equipped with an electrothermal de-icing system. Even the cockpit windscreen has a de-icing system. The Ka-32's versatility is astounding. Its range and all-weather capability make it ideally suited to its role as a search and rescue aircraft. It has an autopilot system that allows a single operator to leave the aircraft in autopilot while he operates a winch from the rear cabin. In addition to a conventional winch rescue, the Ka-32 can also drop a raft pack to survivors in the water. Internally, the Ka-32 can carry up to 16 seated passengers or 4 patients on stretchers. The Ka-32 is used by the Swiss for mountain rescues, while the Russian Navy uses it for air-sea rescues. Ship-based Ka-32s are equipped with ice patrol instruments as well as radar and emergency inflatable floats. It can also be fitted with a spray system for ocean pollution cleanup. Fitted with water tanks, a snorkel pump, and suction hose, the Ka-32 functions as a firefighter. The crane located under the Ka-32's fuselage is capable of lifting up to 5 tons, while its internal cabin can carry just over 3.5 tons. This makes it ideal for its part in logging missions in New Zealand, where the Ka-32 is used to haul trees from remote mountainsides. Kamov proved its ability to design and produce heavy-lift and seafaring helicopters. But in July of 1982, Kamov brought to an end Russia's search for a state-of-the-art attack helicopter. Since the Mil Design Bureau's Mi-24 was adopted by the Russian Army, both Kamov and Mil have been at work designing a helicopter suitable to replace it. Kamov answered the call with the Ka-50 Black Shark. The single-seat Ka-50 first flew in 1982. It is one of the most advanced helicopters in the world. The Ka-50's agility, firepower, and heavy armor defeated Mil's Mi-28 in the race for a Russian attack helicopter. Because of its single-seat design, Ka-50 designers were forced to incorporate many automated systems, including helmet-mounted sights, heads-up displays, and computer-aided navigation systems. By retaining Kamov's traditional coaxial rotor design, the Black Shark optimizes its engine's thrust by allowing it faster acceleration, greater speed, and a higher service ceiling. More impressive than all of this is the Black Shark's unparalleled maneuverability. The Black Shark's weapons systems include a lethal combination of up to 16 laser-guided missiles. It is also armed with as many as 80 air-to-air rockets that are capable of being launched from as far away as 6 miles. All this and a .30 caliber machine gun mounted on the starboard fuselage for fighting at close quarters. Accuracy is all but assured because targets are designated by surveillance aircraft. The Ka-50's lone pilot is protected not only by the aircraft's heavy armor, but by an ejection seat. It operates by triggering an explosion that blows off the rotor blades before shooting the pilot away from the helicopter. The Black Shark is heavily armored and can endure extreme punishment from enemy ground fire. Its defensive systems include self-sealing fuel tanks and armored engines. With the ability to go into battle in both the light of day or on the darkest of nights, the Black Shark is an airborne force to be reckoned with. Russia's helicopter arsenal has leaped forward from turn-of-the-century aircraft that could barely make it off the ground to state-of-the-art gunships that are destined to see Russia's proud helicopter legacy well into the 21st century.
Forward, backward, side to side, and even upside down, these machines can fly almost anywhere. Take an in-depth look at the most versatile aircraft in the world today on Choppers, coming up next on the Discovery Wings Channel.